Es un placer para nosotros tener a Beatriz Milz. Ella nos va a presentar una introducción al paquete, a la programación funcional usando el paquete PUR. Beatriz is una instructora en Tidyverse, certificada por POSIT. Ella es una profesora de R en los cursos de R y consultora de R en los cursos Consult R. Ha sido activa en la comunidad latinoamericana, ha sido organizadora del R-Lady de Sao Paulo y ha sido coordinadora del proyecto de la traducción o la DR por DS. Beatriz is a Tidyverse instructor certified by POSIT. She is a R teacher and instructor for the course R. She is an active R community as a co-organizer of R Ladies in Sao Paulo and Latin R, the project manager of the translation of the R4DS book. It's a pleasure for us for having you here, and Beatriz, the time and space is yours.
Okay, thank you. Can everyone understand me well? Because my native language is Portuguese. Yeah, okay, yeah. We can communicate like that. Okay, so if there is something that it's not clear, let me know that I can like try to repeat in my Portuñol, because my Spanish is not so polished as well. So it's a pleasure to be here. Unfortunately, I couldn't participate in person, but I would love to. And the idea of this talk is to talk about a little bit about the package PUR. Pablo already introduced me, and I think you can keep is that my contacts are in the slides. I send the slides in the chat, so the organizers can give you the link as well. And my email and my blog is here. And most of this stuff in my blog is in Portuguese, but there's some content in English and Spanish as well. As Pablo said, I'm one of the people leading the translation of the book R for Data Science to Portuguese. And I think it's really, really important to mention that this is all inspired by the work that the Spanish-speaking community did before. They already did the translation to Spanish. So they translated the first edition of the book, and now they're translating the second edition of the book. And the leader, I don't know if anyone has heard about Riva Quiroga. Riva is the leader of the translation in Spanish, and she's helping in all the steps to Portuguese as well. So it's really good to see the Spanish and the Portuguese community working together, because we are all in Latin America, right? So the plan of today is to talk a little bit about functional programming, the PUR package, my favorite PUR package functions, and one example of using PUR package like in real life. So let's start. About functional programming, I'm not sure if I cited in the beginning, but my degree is in environmental sciences. I'm not a computer scientist or a statistician. So when I started learning about these words of functional programming and the concepts the books always had, it was a little bit hard for me to understand in the beginning. But I think the most important part is that we use functions when we are programming. We are most focused on using function and applying the objects. So I think this is the most important part about functional programming. Of course, someone from computational sciences could give a long explanation, but in order to follow this presentation, I think this is the most important thing that you need to know. And remember, this is like an introduction presentation, so we're going to talk about some concepts that are useful in order to understand PER. So, as I said, functions are really important when we are doing functional programming, using this programming paradigm. And I'm not sure, I hope so, but I'm not sure if everyone is used to this concept of what are the functions in R. So the idea is a function is a set of instructions that takes an input that we call arguments, and follow with these instructors, we have a result. We call it an output. And why is it important? We can reuse our code in a way that we don't need to copy and paste, for example, a large block of code. I remember when I started learning about functions, I'm not sure what context was that, if it was in the books or in a course or a video, but I remember Hadley Wickham saying, Hadley is the creator of ggplot. He said, if you copy and paste something like 3 times, create a function for that, because if you need to use it again, or if you have to correct something, you just correct in one place and it's going to work. And if you like have the same block of code like a lot of times, if you fix something that you need to change in one block of code and forgot another one in the end, you are more prone to mistakes, especially like human mistakes, copy and pasting and stuff like that. So functions are great. We can reuse our code. So an example, we use functions all the time in R. And instead of like typing or seeing the time in my computer, I can use a function that's called sys.time, and it shows in R what time is today. So this is an example of a function. Is a word with a parenthesis, and when I type that, when I run that code, R opens these instructions and gives a return back, which is the time today in my computer, or not exactly today, but I think the last time I compiled the presentation. So we use functions all the time. So these are some examples of functions in base R that we usually start learning when we learn R, like a library, install packages, C. This is all functions, and these are functions from base R, right? And I think it's important we know a little bit about the structure of a function, because a lot of times when I'm using PER, I just get a code that is working for one case, and I encapsulate it inside a function, and I reuse the function, not copy and paste the block of code. So a function always has a name. So is the name that we use when we want to use the function. A function can have arguments. Not all the functions have arguments. So we type like the name of the function, the assign symbol that we use to create an object. And in order to create a function, we use a function called function. And we put the arguments that we want our function to have. And then we open the curly braces, and inside the curly braces are the instructions that we want our function to follow. And we can have a return value. In R, if we don't put like return, is going to return the last thing that we have in our function code. So, for example, this is a simple example that how can we create a function? I want a function in this example that converts reais, which is the currency we have in Brazil, to US dollars. So I put a name, convert reais to US dollars. It's good that our function has a clear name, so we know what the function is doing. And usually functions, we use names that are verbs, like convert, run, or filter, range. So it's easier to understand what the function is going to use. These are the code that is always the same, because we always have to use the function in order to create it. Reais is the name of the argument. This function will only have one argument, because it's really simple. We could have another arguments, but it's going to be really simple. And inside the curly braces, inside the curly braces, we have the instructions. So the instructions is, I want to get the money, divide by the value of the currency, and save as US dollars, and format it to be more like dollar. And you can see that I didn't use the return function to give it back. R just returns the last thing that my function do. So if I want to convert the minimum wage in Brazil per month, in 1 month, to US dollars, I can use this function, put the value of the minimum wage in Brazil, and it's going to convert to dollars, and is already like formatted because we use this scales function. So this is the idea. And we can do, we can start like writing simple functions, and moving forward to greater functions. And eventually you're going to see that your greater functions sometimes could be like a big function that calls another small functions. And it's really great to see how we can, like, how we like this paradigm gets more easier to follow as we practice more. In the beginning, we start writing simple functions, like getting some code that we know works and putting inside of it and testing. And as soon as we notice, like a year later, our functions are like doing a lot of great stuff. So if someone doesn't know how is the structure of a function, this is how can we start doing a simple one. And this is like highlighted because the last thing in our function is what is going to be returned. So this is the money, the value, but formatted. Another example of a useful function in Brazil, we don't use the date format that R uses. We use like the day, month, and year. And we can use as date to convert the date format, but we have to use always like %D to represent the day, /%M to represent the month, and so on. And copy and pasting this could be prone to errors. Like if you miss like a lower case m to a higher case m, is going to give an error because it's not going to work. So we can create a function. So I just got this code, put it here, and instead of putting the date, I gave the name of the argument. The argument is called date. So when we run the function, it's going to be replaced here, and we can do the same thing as here, but with less code, you know? So we can like get simple code and reuse it in a lot of spaces if this simple code could like have we can have a like chance to get a mistake by typing, for example. This is an example that sometimes we get a typo, and we only know this when the date is like NA. So as soon as we create the function, we can use it, and we can see that it's converting the date from Brazil to a date format that R understands. So these are the concepts that is important to start using per, like what are functions and how I can create a function, because eventually we can start creating a function with per. No, creating functions and using with per. So what is the per package? The per package in the source of this slide is a presentation that I saw from Hadley, and the link is in here. Actually, it's a video and it's really good. So if anyone wants like a great example, you can click here and see the presentation. So per is a toolbox for functional programming. There's a lot of functions that can help us programming with this paradigm. And a lot of functions we can compare to for loops. And maybe if you're good with for loops, maybe you don't need to worry too much about per if you're happy with for loops. But code with per is shorter and more clear than using for loops. And one thing that I'm not going to go further here, but I think is important to know, is that per is this package from Diverse, and there's another package called fur. Fur is it's a package that help us. Oh, it's here. It's a package that help us run code in parallel. So if you have to run a lot of code, you can use fur. And the syntax of fur is the same of per. So if you want to run in one core, per, if you want to use in multiple cores, you can use fur. And it's nice to know that, because as soon as you learn how to per, you can, and if you need to use multi-core sessions, you can use the fur package. I have used it, and it's really simple to migrate from one to another. You basically have to configure like the sessions, but there are some functions that help you to plan these. You have to plan the sessions and how many cores of your computer you want to use, and there you go. You can use just code that is the same from per. One thing that is important is that the per package has been updated recently, and there are some functions that I'm going to show today that are new. So there were some functions that I was really used to using, and they were like superset, and I updated the presentation to show the new versions of the functions that I am already using. So it's important to check if you have the version, at least the version 1 of per, and if you don't have, before you use these functions, update it so you can run the code without getting errors, because like the function does not exist yet. So about my favorite functions, I want to give you a disclaimer that first, I'm not like a wizard for per. I think Hadley is a wizard for per, and in Brazil we have Caio Lente. He's the wizard of per in Brazil. But I basically use per in my work, and I don't know all the per functions. I know the functions that get the work done. So some of these functions can seem like alike, and this is the idea. I don't want to show like 20 functions. I want to show like a handful of functions that can be useful for working together. And we are going to focus on this today. These slides are made with Quarto, and as you can see, when you put them like the mouse and the name of the package and function, it's a link. So if you I want to see the documentation of this function, you can click here and it's going to show the documentation, so it's easier to find. So let's start. The code that I'm going to show here, it's important to cite that I run library tidyverse before. So Porus is part of the tidyverse, the core packages of tidyverse, and tidyverse is loaded. So I'm going to use the function map without the 4 points. So the most important function in Per is called map. And map has like a family of functions. There's map, map2, map double, map, there's a lot of maps. And there's another, like, there's functions that are similar to map, like walk or pmap or stuff like that. But I'm going to show map. And I want you, if you never heard about map, I want you to understand map. And after that, it's easier to go from map to the other functions. So the idea of map is that we give it an object, and it can be like a vector or a list in R. And we want to apply to that object or list a function to each element of the vector or of the list. And map, it's important to say that map always returns a list. And we're going to see how we can avoid that, because sometimes we don't want a list. So the structure is, we call map, we give it the vector or the list that we want to apply a function in each element, and we give the name of the function. And as I said before, there are many similar functions like in the family of map, and they have like similar behavior. So one simple example of per map, I created a vector with the names of the countries that are part of Mercosur, which is Brazil, Argentina, Uruguay, Paraguay. And I want to map to each one of the elements, so Brazil, Argentina, Uruguay, Paraguay, the function str string to upper. So the idea is simple. So what map does is going to get Brazil, put inside the string to upper, and it's going to return Brazil in uppercase, Argentina, str to upper, Argentina in uppercase, Uruguay, str to upper, Uruguay in uppercase, Paraguay, str to upper, Paraguay in uppercase. But as I said, map always returns a list. So we can see that this is a list, like the first element doesn't have a name, but this first element has one element that's called Brazil, and so on. But what if we want a vector to be returned, which would be like, we'd imagine. And like, usually we just like give this vector to str to upper and it works. But I wanted to show this example with maps so we can like understand that this goes to this and returns this goes to this and return this, and so on. So we can think about like the workflow, okay? If we want to return a vector, we can use mapfec. and the idea is like mapvec is the same of map, but returns a vector. And we used to have like, I think we still do this. We have map numeric, map double, map logical, map for a lot of classes, but now mapvec is a function that's more recent that works with any kind of class. So always returns a vector. So it's useful. We want to apply a function to each element of a vector and return a vector. So now we can get a vector. And another function that Per has from this version 1.0.0 is list combine, list C. So the idea is that this function takes a list and return as a vector. So it gets this and returns a vector like that. So the idea is that we don't need anymore these great sets of map double, map logical, blah, 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 a lot of those functions. We just need like mapvec or map with list combine. And there's another two functions which are list rbind and which would be like row bind. So if the input are data frames, the output is a list of data frames, is going to give one data frame with the rows binded. I think it's with the rows binded. And there's also lists cbind, which would like combine the results as columns of a data frame. Another function that is useful, but it's not new, this function has been around for a while, is pluck. And I think pluck is useful because help us extract elements from a list. And it's really useful when we have like a nested list and we want to get an element from like from way down the nested list. It really shines when we want to do that because we don't give the position, we give the name. You also can give it by the position, but you can pass the name of the list, because it's nested lists. Like the idea of nested lists is that we have lists inside lists inside lists. So pluck help us to get the elements from those kind of lists, which we call it nested. And we're going to use the map countries Mercosul Westward to open us string to upper to show the examples. So we can use pluck to get the elements by the position. And we didn't show with the name because usually the name of the list is here, but this list is not doesn't have a name on these elements. So you can also use that, but I didn't put in the examples. And before using pluck, I used to use not the curly braces, the braces. These braces, I don't know, not curly braces. I don't know the name of that in English. Oh, sorry. So I used to use this syntax before, but as soon as I learned how to use pluck, it was really clear to me that it was easier. And one thing that this is an example, right, we can use. In this way, pluck looks like harder, like more code to write, but there's two main main reasons that I like plug more. One is that it's pipeable, so I can use plug easier in a pipeline. And this is really useful when we're doing, for example, web scraping, because web scraping, we're dealing with lists all the time. And if we do something like that with the pipe operator, like in a big pipeline, it's not going to work. And also because plug is safer, because when we try to plug an element that does not exist, it's going to return a null. But if we try to subset an element that does not exist, it's going to give an error. And as I said, it's really common to use plug like in web scraping. In web scraping, use like the mapping a lot. So sometimes we're like applying a function to a lot of lists, and in one of them, if one of them gives an error, like doesn't have an object, it's going to give everything an error. But with plug, like if we use this syntax, but if we use plug, the one that doesn't have the element is just going to return null, and you can still have like the other elements that you've tried to extract. So as I said, there's also list rbind and list cbind that are functions that bind lists that contains data frames by row or column, and it returns like a table or data frame. So the idea now is to see one daily example, and it's going to have like an example of list rbind, and it's going to be more clear why list rbind is interesting. About the examples, when the organizers they invited like based on a workshop that I gave in Our Ladies in Brazil that was like 4 hours, and we had like a bunch of examples, but as the presentation is supposed to be quick, I had to choose one example and in order to fit in the time. So I'm going to show one example that how I use PER in my daily basis, and I think this example is the one that is more general. I think more people can like get something from it. So the idea is I have a folder with multiple files that I want to import. How can I do that? This is really common in Brazil when we are dealing with public data, like governmental data. For example, if I want to get a data set about what the city of São Paulo has been spending, like the budget, they have one Excel file for each year. So if you want to see like the whole time series together, you can download each one and import all of them and try to combine them in one data frame, and then you can start working. And when I started programming, which was like 5 years ago, I didn't know how to use this kind of tools. And I imported each one of them by themselves, and then I was like row bind with the around 20 data frames that I had. So I think this example is good because it helps in the importation part, how to get data inside R, and everyone has to do this kind of stuff in order to work, right? So in order to think in this example, we have to to remember. The map function needs a vector or a list of the elements that we want to apply the function and a function. And so when I want to do something like map something that it's not clear in the beginning in my mind, I try to think, how can I do that with one element? Like, I have one folder with a lot of files, but how can I do that with one file? So if I want to import one file, I can use, and in this example, we have a lot of data frames that has water quality data in the reservoir that I study here in São Paulo. So that's what I said. It's like real life, because I got the data example from one folder that I already had downloaded. So the idea is, if I want to import this date of chlorophyll A in this reservoir between 2018 and 2022, I need to give the path of the file. So inside my project is inside the data directory. There's an example one folder, and is the name of the file and the extension. And I use the function read Excel. I think this is important. What function do I use, and what do I give to the function? What the function needs to work. So we want to apply that to multiple files. And if we want to use map, we're going to use the same function, the read Excel function. And what changes between one file and another file is the path. The path of the file is what changes. And so we need to think about, how can we create a vector with all the file paths? So there's a bunch of ways that we can do that. We can do that kind of stuff with the FS package, which I adore. But here I'm using a function from Bazar that I give a path, like a folder or directory, and it looks inside that directory to find files. And I can give a pattern. For example, here I'm saying, I want to look in the data / example1 folder, and I want only the files that are Excel files. And I want it to return me the full name. So, because if we don't put that, it's going to show only the name of the file, like the name, not the full path of the file. So if we do that, list files will give us this, which is like a vector with the name of the file path. So if we are thinking about mapping, we get the files to import the vector, and we have a function, which is read Excel. So map is going to get, for each one of the values in the vector, each one of the paths is going to pass to read Excel, read the file, save it in a list, and go to the next one. This example is not too big because I copied only 6 files, so we can see the example. But here is what we get back. So we have a list, because you can see that here is 1, here's 2, here's 3. We have a list of tables. So the content of the listed tables. Each list have different values. So we can see that this table has 102 rows. This one has 160 rows. But the columns are all the same, because I downloaded downloaded them from the same website, and the website has like a pattern for the columns, and we have all the same columns. But when we're doing our data analysis, we don't use a list of tables. We use like one table, complete table. So how can we improve this workflow? And this is because map always returns a list. If we see the class of the results import is a list. But we want to bind the data frames by row, because we know that all the columns are the same. We just want to pile them up. So here's where we can use list rbind. So we get the files to import, we pass it to map, and say what function we're going to use, and we bind them together. So the results we're going to have is the data frame with 664 rows, which are all of them together. And we only get one data frame. We don't have like a list. We have a data frame, which is the format that we are used to work with. I hope this example was clear, the example of the rbind. One thing that is important is that before they had a map dfrow function, but this function was one of the functions that was superseded. Before, I just used like files import and map dfrow, and it gave like this result. But map dfrow was superseded, and now the authors of the package recommend us to use list rbind, so that's the new way we're using now. Because it's more general. We can use list rbind not only in this case, but in more cases. So I think the idea is that Per is eventually is going to have less functions that we use in a daily basis, but the functions has more. You can use that for more purpose. So instead of like a double map character, map logical, blah, 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 you're just going to use map factor. You don't need like map dfrow, df columns, and the other kind of stuff to use, or map to dfrow. You just have map or map to, and then list rbind. So it's more general. So some final thoughts. Per is a very powerful package. I use a lot in my daily tasks and more complex stuff. I chose this example because I think that is more easier for beginners to understand the map function with this like opening a lot of files at once example. And today I focus on helping you to start understanding the basics to start Per, but there's a lot of other functions you can learn. So I put it here like some links. They're all in English. So this is the documentation of the Per package. This is a post about the news in the version 1 of package. This is a video of Hadley explaining these new functions of Per. And this is the book R4 Data Science. In this book, there's two chapters that can be useful, which are the chapter that explains function and the chapter that talks about iteration. So here there's more examples. There's one example that's similar, like reading multiple files, but there's also like saving multiple files and stuff like that. And these two chapters are really good. And if it's hard for you to read in English, I recommend you to check the version of the book that was translated to Spanish, because there's always also content about iteration in this book, in the first version of the book, first edition. So this is a great way to learn, but remembering that this is using like the idea of math that has a lot of functions, And the way that I showed you is like, instead of using map logical, map int, map double, map character, you just use map fact. Which is something kind of new. So, I think that's all. Yeah, this is the last slide. I hope it was understandable, my presentation with my not so great English, but I hope you could enjoy the presentation. Thank you.
Thank you, Beatriz. It was a good presentation. Thank you very much for your contribution. I would like to ask the public if they have any question.
Okay.
Si la quieren hacer en español, la pueden hacer en español, la pasamos, o si la quieren hacer directamente en inglés.
Good morning. Thank you very much. I want to ask, what is the difference between the use of maps and pur packages and the use of the applies functions? Lapply, sapply, and the rest of the base apply functions in R.
I'm going to be totally honest here. When I started learning R, when I learned, I like people in my work and people that I study with, they didn't use a apply or a supply, and they all use pur. So I didn't learn from that. So I'm not sure I could answer you properly because I don't use those functions. So sorry. I'm more recent. I've been like programming for 5 years, so I'm already like the per generation.
Okay, thank you.
Sorry.
¿Alguien tiene alguna pregunta? Okay, Beatriz, thank you very much for having you here and share with us this knowledge, and we hope to see you again in the next event. Thank you very much.
Hopefully in person. Hopefully in person, because I want to go to Colombia.
That will be great.
Thank you.
Thank you. Bye.
Thank you. Bye.